Hello, gentlemen. Have a great day. This is page number 144. The question: why is actuator alignment of control valves so vital? Answer: defective or incorrectly specified actuators can lead to severe valve leakage problems. They can subject to valve components to undue stress, jam a valve open or shut, short stroke, or fail to stroke when required. Question: actuator mounting is one of the most critical aspects of valve installation. In the past few years, there has been a growing trend towards field mounting of actuators. What are the specific guidelines that should be given particular attention when installing actuator in the field? Answer: always follow the manufacturer's instructions when installing actuator in the field and apply common sense. 1. Check whether the actuator output shaft and stem aligned, are they parallel. If the actuator fails to meet these criteria, be sure the actuator will put a side load on the valve stem and case the packing to wallow during cycling. Obviously, this will cut short packing life. Second, look out the anti-vibration hardware supplied by the valve manufacturer in their linkage kit. If this hardware get overlooked and the valve manufacturer's kit is not used, be sure it will culminate the loosening of the packing follower system during cycling. Examine the valve design and apply common sense engineering. It may reveal the need for such locking hardware. 3. Verify the rigidity of the linkage package by observing its behavior during bench testing. If the mounting kit flexes elastically or plastically to the extent that shaft misaligns during the stocking process, all the efforts to align shafts and to avoid the loosening of the fasteners will go in vain. Question: what is the positioner? Answer: positioner is a device for varying and keeping the actuator position in control all applications. It is a device for varying and keeping the actuator position in control valve applications. The duty of the positioner is to compare actual actuator position to the desired actuator position and thereafter to adjust the pressure applied on the actuator until the desired position is attained. This is the diagram of integrated compact control unit containing the cylinder actuator, the positioner and the limit switch. So the actuators, they can be pneumatic or electro-pneumatic and single or double acting. The next question: what is Quadra Power 2? Answer: it is versatile spring diaphragm actuator, Nails Jamesbury product designed exclusively for on-off and control applications of quarter turn rotary valves. Question: what are the advantages of Quadra Power 2 actuator? Answer: completely field reversible by simple inverting it. Fail to open or fail to close operations can be quickly changed in the field without disassembly. Can operate a wide range of apply pressure 1.4 to 6 bar gram. Ensure safe and reliable operation even with minimal supply pressure. And this is the diagram: pneumatic positioner left one and the electric pneumatic positioner right one. Source: the valve book, Nails Jamesbury publication. The next diagram we can see the Quadra Power 2 actuator. Source: Current 3 1993. Fourth advantages of Quadra Power 2 actuator is two-stage epoxy coating outside and inside, budgets extended protection in corrosive environment. Question: what are the special features of Quadra Power 2? Answer: this actuator combines the extremely pressurized flow control typical of spring rolling diaphragm designs with the torque capabilities of piston actuators. The combination makes the Quadra Power 2 extremely suitable for visually and process control application. The diaphragm plate support system makes it impossible for the diaphragm to pinch on itself, eliminating the need for diaphragm change. Question: what is acoustic control? Answer: acoustic control affects the noise level by virtue of acoustics. This can be achieved by either dividing the flow into multiple streams or by modification of the acoustic field. Control valve aerodynamic noise is mainly caused by dipole sources when the flow velocity is subsonic. An aerodynamic dipole consists of two monopoles pulsing 180 out of phase near a solid boundary. In this case, the acoustic intensity is given by P squared rho squared into V, v power 6 into D squared J divided by R squared, where I acoustic intensity, rho density of jet, V velocity of jet, dj diameter of jet, or distance from source. Note: the noise intensity is proportional to the sixth power of jet velocity. High-speed jet noise generated by aerodynamic quadrupoles, which consist of two dipoles pulsing in opposing pairs. The noise intensity is, in this case, is given by I equal to rho squared into V power 8 into dj divided by R squared. The noise intensity is proportional to the eighth power of the velocity. Thus, the division of flow into multiple streams is very effective in reducing the intensity of noise. This is due to the fact the noise intensity generated by a single orifice decreases rapidly when the hole diameter is decreased. SPL1, SPL2 equal to SPL1 minus 3 into dB. Effect of increasing number of holes on noise level. Source: Flow Control Manual, Niles Jamesbury publication. Thus, a number of small holes attenuates noise more effectively than big hole. A rule of thumb is that each doubling of the number of holes reduces noise by 3 decibel. Source: Flow Control Manual 1994, P16 7077, Niles Jamesbury publication. Question: in order to close the feed of natural gas of boilers in case of emergency, ESD, emergency shutdown, valves are installed. What are the basic requirements of an ESD valve? Answer: the most important requirement for an emergency shutdown valve is that it must close with completely reliability through remote control in an emergency. The closing energy must be stored in the valve actuator, basically in the form of an energized mechanical spring. Spring to close is the most commonly used actuator mechanism. The second requirement is the fire-safe construction of both valve and actuator. The actuator must close the valve before it seats. Bearing and solenoid valves are destroyed. The valve must be tight and the temperature cased by fire. This is a measure to ensure that no gas leak to the fire. The third important requirement is very quick closing time, usually 2 to 3 seconds. Question: why are ball valve and butterfly valves the most suitable candidates for ESD applications than gate or globe valves? Answer: emergency shutdown valves must be very quick acting. During quick operation, rotary valves require smaller inertial forces than gate or globe valves. In ball and butterfly valves, this advantage is greater the larger the nominal size and the higher pressure class of the valve. To ensure the economical and quicker acting actuation, these valves are equipped with pneumatic or pneumatic spring return actuator so that the operating energy is stored in compressed air or in a mechanical spring. Rotary valves and spring return actuators permit a very short closing time to be reached. Question: which one between ball and butterfly valves is more economical for ESD applications? Answer: butterfly valves. Why? They are generally lighter and require less torque, making for economical ESD valves. Question: under what operating conditions are butterfly valves mostly used in ESD services? Answer: they are used chiefly in low and medium pressure services, in medium and large dia piping. At high temperatures, metal sheets are required. Question: when is a ball valve is the best solution? Answer: for demanding applications. In most demanding ESD applications of high temperature and higher differential pressure, fully metal sealed turn-on mounted ball valve is recommended. Note: steam ball valve of Niels Jamesbury is an outstanding example of ESD application under demanding environment of extreme temperature and higher differential pressure. Thank you for now.